All right, welcome everybody. This is section 8.4, fundamentals of probability. So we want to look at these probability models that they have. And this question says, determine whether the following are probability models. First of all, you cannot have no negative probabilities. You're not allowed to have a negative probability. That's the first thing. Second thing, probabilities have to add up. Probabilities have to add up to 1. I'm not doing roll, Calvin. So no roll call. No more roll call because I can't drop you anymore anyway. So no negative probabilities, and probabilities must add up to 1 to be a good probability. Determine whether the following probability models are true. Look at this first one right here. 0.4, 0.3, 0.1, that adds up to 0.8, 0.8 plus 0.4. This adds up to 1.2. That's not a good one because it doesn't add up to 1. You see, it has to add up to 1 or 100%. It cannot add up to more than 1. This must add to 1. So if we look at this one, add all these together on our calculator, I do get 1.0. So this is a good probability model. This one, as soon as I see a negative sign, you can't have a negative probability. So that's a bad one. Bad, bad, good. So 1B is the only good probability model. You can't have a negative probability, and you cannot have probabilities that add up to something other than 1. They must add up to 1. They can't be higher, can't be lower, but they all must add up to 1. Construct a probability model for the following. A fair dice is tossed twice. So we're going to toss 2 dice. Hey, somebody, make sure your microphone's off when you're talking in the background.
Okay.
A fair dice is tossed twice. Construct a probability model. I could have a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. A 2 and a 1, 2 and a 2, 2 and a 3, 2 and a 4, 2 and a 4, 2 and a 5, and 2 and a 6. You see on the dice, I could have a 3 and a 1, 3 and a 2, 3 and a 3, 3 and a 4, 3 and a 5, 3 and a 6. You really have to put them all up here. A 4 and a 1.
Isn't it supposed to be a coin?
3, 4, 4.
Yeah, it says coin.
Says what?
It says coin.
Yeah, on here it says coin.
Oh, that's even easier. Thank you.
A guy tried to explain it to you, but
I couldn't hear. I thought he was talking in the background. I'm sorry. So we have heads or tails. So I have a head and a head. I can have a head or a tail. I can have a tail and a head, or I can have a tail and a tail. So there's 2 coins. And this is the probability model. And it says construct it. If we look right above it, the prior probability model, and there's the different ways of looking at this, but do you see there's an outcome and then there's a probability. So that's what we're going to do here, outcome and probability. So we're going to have an outcome and the probability. The outcome we could have is 2 heads. And how many options do I have for 2 heads?
1.
1 out of 4. So the probability of getting 2 heads is 1 out of 4. And we can change that to decimal equivalent, which is 0.25. The probability of 1 head. There, do you see this one and this one have 1 head in them? So that's 2 out of 4, which is 0.50.
2.
And then finally, 0 heads. And the only one that has 0 heads is that last one. It's 1 out of 4, or 0.25. This is my probability model. If you look at it, add that up, it does equal 1. So the outcomes are 2 heads, 1 head, or no heads. And the probability for each are there. No heads, there's only one that has no heads. This one, 1 out of 4. 1 head, there are 2 of them. There's a head and there's a head, only 1. So 1 head, there's 2 answers out of 4, and so on and so on. Okay, so let's see what else we have.
How come you don't do a probability for one tail as well?
Well, you could do it. It's the same thing, by the way. No, one tail is the same thing as 1 heads. Do you see? If you have 1 head, that means you also have 1 tail. So you could have wrote 2 heads, 1 head, 0 head, the outcome, or you could have wrote the outcome if you wanted to. You could have wrote 2 tails, 1 tail, and 0 tails. The answer would have been the same. Do you see 0 tails is only 1 out of 4, 1 tail is 2 out of 4, and 2 tails is 1 out of 4. It still adds up to 1. And I just use heads. It didn't tell me which one to use, heads or tails. Normally it'll tell you, but either way, the answers are going to be the same.
Got it.
Okay, number 3. Let's bring that up. Suppose now the coin from the last example is not fair. So let's just scratch this because we're not going to do anything that's not fair. Everything on the test is fair. That means, I mean, some coins, if it's weighted differently on one side, it'll produce heads every time or whatever. So anything that doesn't say not fair, we're not doing. Moving on. So next problem, calculate the probability. By the way, to do probability, it's the number of outcomes, on top divided by the total number of desired outcomes. Let me say desired outcome, and the total possibilities on the bottom. So that's the probability. Calculate the probability of a family tree with 3 children will have all boys or all girls. What is the probability of having? So let me just show you. We have 3 children. If you have 3 children, you can have a boy, boy, boy. You can have 1 boy and 2 girls. Another way of saying 1 boy and 2 girls is girl, boy, girl. Or girl, girl, boy. You see, the first kid is in the first spot, second kid, third kid. 2 girls would be girl, girl, boy, girl, boy, girl, or boy, girl, girl. So here's no girls, no girls. These 3 are 1 girl. Wait, oh, these 3 are 2 girls, sorry. 2 girls, and I got to erase those others because these are the same thing. And now I got no girls, I got 2 girls, and I want to do 1 girl next. 1 girl. Girl, boy, 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 girl, boy, or boy, boy, girl. So if you count them, there are 1, 2, 3, 4, 5, 6, 7. I'm missing 1. No girls. 2 girls. This is a
No
girl.
boys.
All girls.
No. Yeah, no. Yeah, all girls. There we go. All girls. 3 girls. I forgot 3 girls. Girl, girl, girl. So there's 8 total. How do I know? I have 2 choices, boy or a girl. You have 2 choices. And there are 3 spots. 2 to the 3rd power equals 8. So there are 8 possibilities. So we have 8 possibilities. First, we're going to find the probability that we have all boys or girls. So all boys or girls. Now, the big thing here is know that or means you're adding them. And means it's happening at the same time, but or means you add them. There are 1 out of 8 that's all boys. Do you see right here? This is all boys. Only 1 out of 8 total. And girls, all girls is 1 out of 8 also. Here's the other one. When you add those together, you get 2 out of 8, which reduces to 1/4. So finding the probability of all girls or all boys, or means you add the 2 together. 1 for all boys, 1 for all girls. So that's 2 out of 8, which reduces to 1/4. Okay.
Sir,
Yeah, go ahead.
the question says, what's the probability of having 2 girls and a boy? Not all.
That's the second part, isn't it? Calculate probability with the 3 children have
It's
all
the
boys
same
or girls.
problem.
Oh, yeah, you're right.
There is
you're
a
right. I'm
second
sorry.
part. All right, so
sorry.
I'm going to erase this. Let me. Oh, I shouldn't erase that part. And there was a girl here. 3 girls. Find the probability of having 2 girls and a boy. So that means means or means the first one, or means add them, and means at the same time. So we don't add them, same time. So 2 girls and 1 boy. How many 2 girls and 1 boy? Right here, there's only 3 of them. Exact, and 2 girls and 1 boy. There are 3 out of 8, and we're done. That's it. You can look, if you have all the possibilities written down, we have 8 of them written down. Find out how many have 2 girls and 1 boy. And there's 3 of them, 3 out of 8. That's the probability. If they want the decimal equivalent, you put it in your calculator. 3 divided by 8 is 0.375. Same thing, decimal equivalent. All right. I can hear the birds. Okay, so now we have a dice, and it's fair, so that we're going to be using it. Fair means it rolls evenly. Let E be the event rolled an 11. Roll an 11 number, and let F be the event 5 or 6. First of all, a fair dice is rolled. Wait, suppose a fair dice is rolled. Let E be the event. Roll an even number and let F be. Oh, and I thought I said 11. Did I say 11? An even number.
Yeah.
And 5, 6. So you can roll a 1, 2, 3, 4, 5, 6 on a dice.
Yeah.
This means intersection. This also means and or intersection. So the probability, first of all, E is the event that's rolled an even number. The set that's an even number is 2, 4, and 6, right? That's the set that's an even number. The set F is 5 or 6. Do you see F is the event that 5 or 6 is rolled? And we've already talked about intersections and unions. The intersection is what's in common. What's in common between these 2 sets. And the only thing in common is the 6. So the answer to this set is just 6. But that's not the question. It says write the event E and F. Well, this is the event E and F. Here's E, here's F, and the word and is intersection. What does this N stand for? Anybody remember?
All right. You wrap it up, no?
It's the cardinal number of the set.
Right.
So what is the cardinal number of this answer? This is the answer. The cardinal number is how many numbers are in that set. And the answer is just 1. Do you see there's that n means what is the cardinal number? And I mean, this is the answer to E intersect F. The answer is the set 6. But the cardinal number of E intersect F is 1. There's only one item in the set. So the n in front of it means how many items are in the set, the cardinal number, how many different items, and there's only one item in the final answer. So now it says write the E or F. Or is union. So once again, E was 2, 4, 6. These are the even numbers. And the F was 5 and 6. And here, or stands for the union or the marriage. Remember, or was the marriage. And so when I marry these two, I got a 2. I got a 4. I got a 5. And I have 2 6s, but we only write down one of them. And this is the answer to E union F, but it asks what is the cardinal number? And there are 1, 2, 3, 4. So the cardinal number of E union F is 4. There are 4 items in that set. Okay. Let's compute the probabilities now. We're not doing cardinal numbers anymore, just the probability of E. The probability of E is the number that's desired divided by the total outcomes. Well, when I roll a dice, there are 6 total outcomes. 1, 2, 3, 4, 5, 6. The probability that is even number, how many are even on a dice?
3.
Yeah, there's 3 of them. 2,
3.
4, and 6 is even. So the probability of getting an even number is 3 out of 6, which reduces to 1/2. 50%. Then there's 50% of getting an odd number. Compute this probability, E intersect F. Didn't we do E intersect F right here? E intersect F. What's the probability of just getting that? Well, there's only one answer out of 6. So, you know, this is the outcome. This is the total. This is the outcome, that desired outcome is 1. You see, this is the first one from A. This was the answer, E intersect
sir?
F. Yes.
You forgot. On C, there's also the probability of F. There are 2 answers.
Oh, okay. So the probability of F, I'm sorry. So this was the probability of E. And the probability of F, if you look for F, there were, where was F? Right here. F. F was 2 numbers. F has 2 numbers. 2 out of 6, which is 1/3. Does everybody see how F in the very beginning, F was 5 and 6.
Oh yeah, that's right.
So there's two numbers out of 6, and that reduces to 1/3. So that's F. The probability of F, and this is the probability of E. And I'm going to erase this and scroll this up. Maybe I shouldn't have erased it yet, because we still have to do, oh, there's 2 answers. So the probability of E intersect F. Didn't we do these? Oh, what did we get for this answer? We got just 6, right? We just got 6. So that was the probability of E intersect F. The answer was 1 out of 6. There's only one number out of 6. The probability of E union, for union, we had 2, 4, 5, and 6. That's what we got previously, the union of those two. So the probability, we have 4 answers out of 6, which reduces to 2/3. So you always look at, this is the desired, that's on top. There's only one answer there, and then the bottom is the total outcomes possible. There's 6 outcomes possible. 1, 2, 3, 4, 5, 6. I keep on getting these ads that pop up. I wish I could stop that. I think I have to delete something on my computer. Suppose 2 6-sided dice are rolled. So let's roll a 6-sided dice. 2 of them. I want to get a 1 and a 1, 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5. This is where I do that. 2 and a 2, or 2 and a 1, 2 and a 2, 2, 4, 2, 5. I would actually, if I was you guys, I would write all these down, because 3, 1, 3, 2, 3, 3, because you're going to need this on the test. And it's good to have it right in front of you. Let's see, somebody type something into the chat box. That's fine. There's no roll today. I'm not taking roll today. 4 and a 1, 4 and a 2, 4. My pen again. 4 and a 2, 4 and a 3, 4 and a 4, 4 and a 5, 4 and a 6, 5 and a 1, 5 and a 2, 5 and a 3, 5 and a 4, 5 and a 5, 5 and a 6, 6 and a 1, 6 and a 2, 6 and a 3, 6 and a 4, 6 and a 5, and 6 and a 6. So if you count these, 6 times 6, there's 36 possibilities. So the total possibilities is 36 on the bottom. If you count all those, there are 36 ways of rolling 2 dice. So find the probability that the sum of the numbers is 10. So let's circle all the numbers that add up to 10. There's 1. There's 1. And there's 1. Anybody see another one? I think that's it. Those are the only 3. So there are 3 out of 36. The probability of getting a 10, there are 3 numbers that get me a 10 out of 36 total possibilities. And this reduces to 1 over 12. It reduces, or you can change it to a decimal, but it reduces to 1 over 12. They both divide by 3. So it's good to have all 36 of those written down. What if they say, what's the probability that they add up to 8? So you have to find out how many add up to 8. Unless you don't have to write them all down. If you can figure it out in your head, that's fine. Everybody okay with that one? Okay, next. Suppose 2 parents each have 1 healthy gene S. Oh no. And 1 sickle cell gene S. Oh no. Find the probability that parents will give birth to a child. Okay, so 1 parent has S and 1 parent has little s. So you could have, both could have big S. One can have a little s, so you can have a little s here and then a big S, or both can have a little s. That sickle cell trait is the little s. There we go. So there's only 4 probabilities here, 4 possible ways. And 1 healthy gene. The big S is the healthy. And this is the sick, the sick one. Okay, what's the probability being, find the probability that the parents will give birth to a child who is healthy. Healthy means they both have the healthy gene. The child has healthy from the parent, from the father, and healthy from the mother. So there's only one that has big S, 1 out of 4. The one that has sickle cell trait, if you have 1S, that's the sickle cell trait. So there's 2 out of 4 that have a 1S, which is 1/2. And finally, the sickle cell anemia, that's bad. That's when you both have the small s. When you have both the small s, that means you do have sickle cell. When you get the bad trait from your mother and the bad trait from your father, that means you have sickle cell anemia, and there's only 1 out of 4 there. So healthy, these are healthy. These two have the trait because they just have the small one, and the 2 small ones, you're sick. You have the sickle cell anemia. I'm still not sure what sickle cell anemia is, but I know it's bad. I know it makes people really tired, I think. Alrighty. Number 8, a fair dice is rolled a number of times, and the number of times that 5 occurred is recorded below. Calculate the empirical probability. Number of 5 times occurred. This is, remember, this is the desired. We're looking for a 5. 3 out of 10 rolls was the probability. Here, 15 out of 100, which reduces to 3 out of 20. 159 over 1,000, and that doesn't reduce, I don't think. Oh, no, they don't divide. And then this one is 1703 divided by 10,000. And you can change it to a calculator to the decimal if you want, but that's fine. Just like this. These are pretty simple. Okay, this might be a little bit harder. It's really not. It's just a table with a lot of stuff on it. In a recent survey, there are 1,056 voters. And if you look right here, there are 1,056 voters. Let me show you what the table does. It adds up all the Republicans. Here's all the Republicans. It added them all up. And it says, what is your most important problem you're facing? So here's all the Republicans. They added up to 533. Then they added up all the Democrat votes, and they got 523. Then you added it going down, and you get this. Now, also, since we can add economy going down, 213 and 211, or 243 and 211 equals this. If I add these two up, I get this. You see, 58 and 25 equal 83. So you can add going down and get the totals, or you can add across and get the totals. But when I add all the totals this way, I get 1056, and when I add the totals this way, I get 1056. So you should get 1,056 total. All right, so I just showed you how that table worked. Now let's do the actual probabilities. Let's see what it says. Find the probability that a participant is Republican. If a person is selected at random, how many Republicans do we have? So the desired outcome is Republican. The total participants is right here, 1056. Republicans are, anybody?
553.
Yeah. The Republicans, we added them this way, and those are all the Republicans, 533. So this is the probability of somebody's a Republican, 533 out of the total, 1056. Find the probability, find the probability that the participant said foreign policy is the most important part. How many people said foreign policy? Do you see foreign policy? You have to add them up.
98.
Yes. 98 out of 1056 total. So foreign policy, these two added up to equal that, 98. That's not too bad.
This
So
is
far,
actually really easy.
so
And
far,
do you want
so
that
good.
reduced as well?
Yes, whatever that reduces to.
49 over 528.
Okay, yeah, I'm not gonna write that down. But yes, reduce all fraction, reduce. Find the probability the participant is a Democrat who said healthcare is the most important issue. Okay, so this is kind of important here. So we want to find my pen. There it is. The probability that healthcare is the most important issue. So we're doing C, right? Healthcare is the most important issue, but we're only talking about the Democrats. Find the probability that they're a Democrat. So when we do total, we're only doing the total of the Democrats.
Huh, I was right. That's what exactly I was thinking about.
Yeah, how many Democrats are there?
523.
And so now we have to see how many healthcare there are. If you look, find the probability. So we're only looking at the Democrats because it says only the Democrats. So we're only looking at the Democrats. And how many Democrats said the health care?
123.
123. So it's 123 out of 523. So we're not looking at everybody. We're only looking at the Democrats. There's 523 Democrats, and 123 said health care was their number one thing. So whatever, does that reduce or?
No, it doesn't.
Okay, just checking. And the same thing goes for this D is the same thing. It's given that they're a Democrat, we know there's 520. Yeah, this is C, right? Yeah. So
Yeah,
D, question?
yeah. Why wouldn't it be 123 out of the 1056 on C? Because it's probability of one Democrat out of all of the people.
No, it says because find the probability that they're Democrats. So we're only looking at the Democrats. Only the Democrats are participating in this next lecture or whatever it is. Find the probability that they're Democrats. And so this is the total. We're looking at the total, just the Democrats. And the number of healthcare that the Democrats said was 123, and these are just the total of the Democrats. Because it said that we're looking at only the Democrats. Same with the next question. Given that we're only looking at the Democrats, even though it doesn't say that, but that's what it means. Given the participant is a Democrat. So in this probability, we're only looking at the Democrats. And how many of the Democrats thought illegal immigration was the most important issue?
78.
98? Is that what you
78.
said? 78. Okay, 78. So that's the answer. So you got to make sure. In the previous problem, it was talking about the whole thing. It just said, find the probability of participants who said foreign policy was the most important part. So they didn't say we're looking at the Democrats or Republicans. We're looking at everybody. Here we said only looking at the Democrats, and we're only looking at the Democrats. All righty.
Yeah, I'm still confused because the way I'm reading it still looks like they're just looking at one Democrat out of all of them. So
Wait, hang on. Let me take a look. Which one? C or
on C? Yeah.
C? Find the probability that the participant. Yeah, they're only finding one. They're only going to look. What's the probability that they pick somebody and they're a Democrat? I mean,
Well, but
with
if
the
you're
health
looking,
care. Well, what was the total for Democrats again?
But then they're going to be all Democrats, so it doesn't make it.
But who had health care as their primary? See, the top is the desire to health care. How many Democrats wanted health care as their number one issue?
123.
And there were only 500 and something total Democrats.
523.
Do you see? It's the participant is a Democrat, and healthcare is the most important part. So we're only looking at the Democrats, and 123 had healthcare. So if I pick one person out of all the Democrats, I have a 123 out of 523 probability that healthcare was their number one issue. You see, put that in your calculator. So it just says if I pick somebody that's a Democrat, I have a 23% chance that the healthcare is their number one issue. And you can look at, this ends up being 0.235, which is 23.5%. That's what that means. And the same thing when it says given. Given is the same thing as we're only looking at the Democrats. So the bottom number will be the Democrats. So, and those tables, we're not looking at everybody. They said, oh, if we're just given that we know the person's a Democrat, we're only looking at the Democrats. Find out the probability that they're illegal immigration. So the illegal immigration would go on top, divided by the Democrats. And that is 5.4. I say try the homework and get back with me, and we can go over some homework problems. If you have any questions on them, let me hit stop for this recording and then start again.